Hiya, so hopefully I'll be taking you through a workshop tour of marketing attribution today. Out of interest, how many people have been involved in marketing measurement projects at their various companies in their personal lives? If you can raise your hands. And of those, how many would say they've worked with marketing mix models before? Well, these technical bits are for you. Okay, so yeah, so firstly, shameless plug. I work at Wise. It's a global technology company, and we're hoping to build the best way to move and manage the world's money. We have 12.8 active million customers. We move billions across borders each quarter, and our mission is minimum fees, maximum ease, full speed. With one of our core tenets being lower costs. This is actually where marketing attribution and effective... Oh, okay, sorry. Speak a bit louder. So this is where marketing measurement comes in. We can lower costs. The more we scale with getting new customers, the more we don't waste marketing spend. This is how we lower our costs. So the outline today is first I'll take through marketing attribution. So we're going to be going through the motivations of these projects, marketing mix models, and why you might turn to Bayesian approaches. Various steps you should take before you code. This is knowing what your goals you hope to get out of your marketing measurement, knowing the limitations of these modeling approaches, and knowing your data. How you can make more informed model designs by using structure, constraints, and various testing observations. How you can validate these results with sensitivity analysis, alignment to track data that you do have remaining, and tests. And then finally, how you iterate as a team with your marketers, with your data analysts, with your data scientists to coordinate and make recommendations on tests and budgeting spend. So firstly, what is marketing attribution? So there's this common adage that a lot of people have probably heard about half the money in advertising being wasted. But this is quite an old adage. I don't know about you, I don't think they had Facebook in the 1920s. But unfortunately, this tends to hold true to today. We see a lot of wasted digital ad spend particularly, and this is before we even go into fraud. So we have this whole realm of marketing data science. And one of the most things that we look at is the customer journey. So the interactive ads, they may convert, start business with your company, and have some early interactions. From this, we'll have an attribution model. This is how we get things like cost per acquisition. And we'll have an LTV model where we look at early customer activity to get LTV. And when we're typically talking about marketing channel measurement, we're looking to optimize this payback, this ratio of LTV over cost per acquisition. And interacting with this is also incrementality testing and more precise measurement that's going on in the background of experiments in new channels and getting more precise measurements of what a channel is actually driving for you. This is things like geo-tests. And then long-term in the customer lifecycle, we're looking at customer relationship management. We're looking how we cross-sell, how do we do uplift modeling, how do we see heterogeneous customer impact from all these marketing activities we're doing. But what we're focusing on today is attribution modeling. So originally, a lot of this was done with tracked attribution traditionally. We'd have customer journeys like the one shown where they might interact with TikTok, Facebook, an invite link, a paid search click. And then we might do a bunch of different approaches to tracked attribution. We might say, hey, I think I'll ignore TikTok, it's 4 months ago. Did that really do anything? I think Facebook was the first interaction. I'm giving 100% the credit. This is first touch attribution. If I gave 100% the credit to paid search, the last touch point, that's last touch point attribution. But the summary basically is journeys like this don't really exist anymore. We're losing a lot of our tracked data. And tracked attribution, while it's reactive, as in we have these simple customer journeys, we see them live, we can easily say, give a number, it's more directional than it is the whole attribution solution. And this feeds into basically what it boils down to a loss of touch points. So we see this increase of user privacy. We have cookie depreciation. We have iOS permissions for those that have the horrors of dealing with that. We have VPNs. We have ad blockers. We basically have this huge cohort of customers that come to us, and we have no previous touch points on whether they interacted with any of our ad media. We have untracked channels that never could be measured through these methodologies, like TV. TV, we don't have click touch points. We show a TV ad to thousands of people. What was the impact? Don't know. And then it kind of leads us to this idea that tracked attribution can't really capture incrementality anymore. We don't have these complex user journeys. And while it might provide correlations, we don't necessarily have a causal measurement through this solution alone. And this brings us to marketing mix models. So these models learn the relationship between daily paid marketing investment and your KPI. It's a privacy-first measurement. There's no cookie or user level data needed. It's an aggregate level model. To get a bit more in the weeds, it's a single layer linear regression essentially with some fancy bits added on with transformed media. So basically you can see we're doing daily registrations, for example. We have baseline terms for just customers that come to you from like brand awareness. We have growing trend over time, so perhaps your brand awareness is growing in your market. Seasonality, are you a seasonal product? So you get more customers in the summer maybe. And then you have the daily impact of your paid marketing and your organic. These can come in the forms of daily spend, daily impressions, or daily visitors. And these come in the form of demand, what we consider more demand generative. So things like paid social, TV, and things that are a mixture of demand capture, where there may be background demand driving people to come and use affiliate links and use invite links, but they are still driving some incremental value on top of this background demand that's underlying driving them. And then there's, of course, external factors that you may choose to model that are exchange rates, your price, product offering, marketing competitors, these sorts of things. And you typically have 2 to 3 years of marketing data. So we don't just model ad media directly. It's not just looking at daily spend. We'll do some transformations on this using what is commonly considered how this marketing works in the real world. So the first thing is carryover, the concept of delay and spread of impact. I see an ad today, but I might register or convert tomorrow or in the following week. So channels perform very differently depending on where they are in the funnel. Higher funnel channels, such as TV, will have longer carryover effects. You might see a TV ad and it takes you 2 weeks to convert. But if I'm already doing a paid search brand click, I'm probably going to convert today or tomorrow. There's also the idea of saturation, diminishing returns. And this is the idea, I cannot 10x my channel investment and get 10x returns. I will eventually just be showing the same people the same ads. And if they're not going to convert the first 4 times, they certainly won't the next 10. So this is inherently capturing the principle of elasticity in marketing. So why might you turn to Bayesian modeling? So it's actually a really good use case here. We have very limited observational data. Even if you have 3 years of data, we're talking about 1,000 data points. We have very strong prior beliefs about modeling constraint, parameters, an example being, I believe the carryover effects for higher funnel channels like TV to be larger than lower funnel channels. And then I also might desire a measure of uncertainty. With especially small channels, it's really difficult to measure them. They're probably going to have a much higher degree of uncertainty. We capture it, we can communicate it. And for those that are very unfamiliar with Bayesian modeling, to put it into simple terms, basically we have prior beliefs about what we think are likely outcomes for the model, and then we have the evidence from the data, and the conclusion we come to is a mix between the two. So it's a more informed way than just coming with a model that will just say, yes, I'm 100% sure it's definitely this one number. So essentially we design a generative model. It's trained to actually predict our KPI, our daily KPI, given our marketing, if you see the graph on the right. And so you see we stack up the contribution of baseline, Reddit, for example, TV regis, and we're just trying to make this stacked graph align with our total KPI for the day. But the problem is there's many stories in what the different channels are doing that can align to this one KPI signal. And this is fundamentally the greatest challenge of MMMs. There are multiple stories that fit the data, which is the correct one. So to go a bit more in detail in Bayesian modeling, so you can think of modeled parameters as they tell the story. And this is essentially learned distributions that capture the confidence in how channels are behaving based on our prior beliefs and observational data. So for example, the carryover effects of different channels, which channels are saturated or not, the impact of day of week on sales. We have prior beliefs. These are which stories are most likely. And so the idea, again, TV has higher carryover than paid search. And then we get into advanced Bayesian modeling, where we might do things like constraints. Which stories are impossible? So you could have a very strong belief, I don't think that less than 30% of my sales are coming from baseline. Like there is at least 30% of sales just coming from background effects in general. You might have custom penalties. So the idea that important story plot points must be adhered to. So if you incrementality tests, you might say that your attribution modeling should align to this. And then you allow also for Gaussian processes that stories can evolve over time. So what are the steps we take before we start coding? So firstly, the most important thing is to define what is your success. The simplest outcome you'll see for marketing mix models is just a holistic overview of channel performance. These saturation curves. What is my current CPA? What would be my incremental CPA if I increase spend, decrease spend? You can make this more advanced by feeding these models into constrained optimizers with the idea that how should I change spend up to 20% for each channel to improve my return on investment? And then this takes us to the more advanced ones where perhaps you want a daily KPI attribution dashboard where you want to say for each day, how many registrations, how many KPI is my marketing delivering? How does that align with the LTV predictions I have? What is my payback on a daily, monthly basis for these channels? And so something to think about is how do you plan to optimize against these marketing activity numbers? What is the level of reactivity that is actionable to your marketers? So for example, the CPA, the cost per acquisition of a channel between model retrains will usually be constant. It will only really depend on where you are on the saturation curve. So something discussed in marketing mix models is the idea that between retrains, if a marketer is above payback, the only way they can improve their cost per acquisition is by going down the saturation curve, decreasing investment. What kind of behaviors is this going to encourage in your marketers? And so basically, you need to start thinking about these and what cadence do you plan budgeting, to optimize marketing, to do post hoc evaluation. These all things influence how you integrate these systems with your companies. And so these comes into what the MMM limitations are. So for example, there's limited reactivity and saturation curves. So if you look at the graph on the top left, they might have all this green spend that you've done historically, and you've done actually very little experimentation at these high ends of spend. The saturation curve you've learned is quite pessimistic. And so in between retrains, they start experimenting at new high levels of spend, but they're getting very poor CPAs until you do a model retrain. You don't react until you retrain the models. A further limitation is reactivity in terms of parameters. Even if you have a way to model how your channel performance varies over time, it's fixed at point of train end date, and it will only start changing again once you retrain the model. If you have a highly variable performance channel and you can only say that the performance was constant from point of train, and if there are significant 1 month delays until model is implemented, 3 months before the next train, you now have 4 months of consistency where you can't report a change in channel performance. And so marketers need to be aware of these limitations, and it needs to be discussed in how you productionize these models. So knowing your market. So how much valid data do you actually have access to? So we use the last X years of data to know what to attribute today, how to evaluate marketing performance today. So it needs to represent present day performance. So more data isn't necessarily better, is the first message. You could have new product directions, COVID, all these sorts of things. You also have external factors that might be influencing your KPI. Now, this might not necessarily be problematic if it's not correlated with your marketing investment, but you should be aware of what background factors are influencing you. And so if you use flexible modeling process like time-varying parameters, you will be less constrained because you allow some idea of model performance to change over your train period of 2 to 3 years. But particularly if you have a static model, then you need to be very aware that you're trying to work out marketing effectiveness today from something trained over 2 to 3 years. Know your KPI. So when does a customer start? Is it your first transaction? Is it at trial, subscription? There's an inherent tension here. We want the shortest path possible from a measurement standpoint between the paid marketing itself and the KPI. You have the least distortions, it's the easiest to model. But in customer attribution, we need to align to point of value. So, for example, signed contracts in a long B2B journey, the first transaction from which we predict LTV. A common approach to this is to backdate points of value to their point of acquirement. So you might backdate the business signed up to their lead date. So you're basically then predicting leads, brackets, that will definitely lead to business signups. And so it becomes much more of a trade-off between these two things. Know your channels. So track data is still there. As I said, it's not the full causal journey. But you can see for highly tracked channels, how does their CPR or CPA vary over time? And so if it's a highly variable channel, as you see from track data, that should be some indication to you that you need to model that channel with some ability to see its performance change over time, or you're not going to be capturing reality. Furthermore, do you want to use spend to represent your marketing investment, or do you want to use impressions? Impressions is popular in the industry because it's more direct relationship, more representative of what's actually happening. But spend can be much more intuitive to marketers. If you have a channel where your CPM varies wildly, they're going to be seeing really nonsensical numbers from their perspective, where they've increased channel spend, say, and because CPM has increased dramatically as well, suddenly they're seeing less returns, and it makes no sense to them. So this is something you should think about. It's not just about what's easier to model, it's about what you're actually going to be able to action on. So excluding problematic test spend. So marketers, they experiment, and they might have bad experiments. They might go into brand awareness versus brand consideration, or things that are less performant. If you have this significant period of test spend and it led to no new KPI, this will kill channel credit just across the board. It's really important that you understand what actual spend represents the typical activity of this channel, and only use that. When you make sure you're modeling sufficiently large channels. So the whole point of aggregate modeling is you need to be able to see an impact on the KPI from the channel investment. And so you can kind of do a back of the napkin approach to this, where you look at what is the max change really, or range of spend you've done in this channel. Do a very rough estimate of a CPR. It could be your average for your market. It doesn't really matter. And then work out what the max estimate impact this channel could have. If it's less than 1% of your KPI, that should be your first indicator this channel is going to be always very uncertain. You cannot overcome a lack of data, basically. Hierarchical modeling can help here. We'll go into that. Understand your spend. So multicollinear, low variance spend in a complex marketing mix is very much one of the big problems. Marketers are not random machines. Some channels investments are very correlated with each other, but here's some very quick things that you should avoid. So there's new investments in channels that are only scaled up with a growing market. You now can't disentangle background growth, which could be anything, from the channel impact. You can have a channel where, let's say, stochastically it varies a lot day on day, but it's around a constant mean. If it's a high carryover channel, that spreading effect acts as a smoothing function, really. And so now there's no signal to measure the impact of the channel. You can have a slow changing channel. Really, we want step changes. So now we have no clear signals about impact on KPI. And also we have channels that are never turned off. So we can't know what that impact of that first X amount is. We can't calibrate our saturation curves. There's just, if you don't have this data, you can't do it. And marketers this needs to be a very close interaction between marketers and data scientists about what data they actually need. And so this goes into planning your spend. It might take 3 months, 6 months to get these projects off the ground. Why not fix the data? You have 6 months to fix the data before this stuff goes live, right? So channel performance is informed by how changes in its investment impact the KPI. We want multiple, strong, clear signals over time with quick step changes in investment, ideally. So prioritize your core channels, channels with high levels of uncertainty, and untested channels where you've no incrementality tests, and try and create these step changes that are not synchronous with any other marketing channel. So this brings us to informed design. So how do we take all this background knowledge we have and make more intelligent models? So one of the things you can look at is omitted variable bias. You don't actually need to know the magnitude of a causal effect. You can already start reasoning about what it might be in the structure of your model and how this can lead to directional bias. So there's an example here of seasonality. So background demand impacts your organic channels, which then impacts your KPI, but it also impacts your KPI more directly. If you don't model seasonality in a flexible enough way, the only thing that will be able to capture those changes are your organic channels. You've now created a bias where the model will explain more of the variation through organic and demand capture channels. So time-varying parameters. So without time-varying parameters, the big limitation is you can only model the average performance over your 2 to 3 year training period. This is very problematic because we usually don't care. We care about optimizing today, not about a year ago. So one way to model time-varying parameters is through a series of independent normal noise. Basically, this is if you believe there is variation, but it's random around a center point, constant point. But this might not work for all channels. If you have a channel that evolves over time, let's say marketers are making it more and more effective, we've certainly at Wise had channels where they've increased in performance 100% over 6 months. So there you're going to need to model your time varyingness as a series of independent normal noise steps that are cumulative summed. It's a sequential step, but each step is treated as a random step. We don't carry momentum forward. And this is capable of modeling channels whose performance dramatically changes over time. Similar to this, you want to model a flexible trend. If you have high growth nascent markets, we're looking at them over 2 to 3 years, they might have a period of explosive growth followed by saturation. With an insufficiently flexible trend, we're going to introduce bias to the model. It's potentially going to favor demand capture activity again. So like one of the most common approaches to just modeling trend is this fixed form representation. You can either be strictly saturating or strictly growing, and that risks introducing model bias. You can instead model it as a time evolving Gaussian process, and here we're actually modeling the slope changing. This is how we carry momentum forward. It's the slope that's evolving over time. We've gone one derivative forward. Hierarchical modeling. So this is the idea that we can allow information to be shared over distinct contexts, e.g. our marketing channels. This will benefit smaller channels massively because they can share information with these larger, much more informed channels. An example is model-wide hyperpariors in the example of, let's say, your distribution of the expected CPRs or CPAs for your market, and all other channels inherit from this. The hypothesis being here that the performance of channels in a market is related due to joint market factors such as brand awareness, the typical LTV we'd associate with this market, and so on. We also believe groups of channels can share characteristics. The idea that like if you start breaking down into, let's say, platform breakdowns, you have Facebook, but it's Facebook iOS, Facebook Android, Facebook web. Do you believe these to have similar carryover, similar saturation effects? And so this way you can model more channels, smaller channels, and still give them more information by sharing information with other larger channels. Intermediate KPIs and indirect effects. So this is the idea that most of the time when we do marketing mix models, we do it as a flat single layer. But this isn't really reality. TV, for example, has indirect effects through branded paid search, for example, and it also directly impacts KPI. There's been some interesting literature talking about how you can say the total impact of TV now becomes its direct impact on the KPI, but you can also model, let's say, brand paid search as a result of a Gaussian process and the impact of TV upon it. You then model the impact of branded paid search, TV, and all the channels together. And then you can basically take the credit that TV was leading into brand paid search and reattribute it back to TV. That's the principle of what we're talking here. And like by having these, we can reduce cannibalization of lower funnel channels. And we can also, by having intermediate KPIs, such as brand awareness KPIs, for example, capture these longer term indirect effects. Like TV tends to lead to a lot more brand awareness, which will more directly impact a brand awareness KPI that would then impact your overall KPI over a longer period of time. Adding range constraints. So constraints are very powerful. They define what model conclusions, stories are possible. So one of the things you can first do is make sure you know your fixed range distributions and functions. We have a logistic function mapping all real-term numbers between 0 and 1, and we have a beta distribution, which only falls between 0 and 1. We can then scale these. This is really a powerful concept within Bayesian modeling. I give an example done by Recast. I recommend looking at their technical docs. They do an intercept or background impact of marketing that is basically constrained between an upper and lower bound. They use a logistic function to do this. You can also limit various effects, transformations we use in our models. We want to avoid spurious correlations. The more flexibility we give, the more a model might just come to a very radical conclusion just because it fits the data better. So for example, at a carryover of like 0.99, this is between 0 and 1, you're already saying after 90 days, you're at 40% of your peak impact of this channel. You can reason that's as much as you really want to go to top. So you can basically take a beta distribution, times it by this max number, and it will never go above this max number. Recency weighted log likelihoods. So basically, this is the idea that models are trained over 2 to 3 years. typically to use in present day? Does it make sense for channel performance from 3 years ago to have the same influence as channel performance from yesterday? And so if we weight our penalties in this model by their distance to present day, we can basically make the model align more to current performance than from performance 3 years ago. It's the idea of adding more weight to data that comes nearer to present day. I'm going to skip these because I'm running out of time. Okay, so how do you validate your models? So first, you can do channel inclusion sensitivity analysis. So for example, if you have the hypothesis that lower funnel channels cannibalize credit from upper funnel channels, then you can test for this. You can model marketing mix models with and without your lower funnel channels. If you see here, if you see a huge uptick in credit to a particular channel when you remove those lower funnel channels, that's your first warning sign that that those channels may be cannibalizing them. And you can go further and you can model MMMs without all organic and lower funnel channels. And this is kind of a way of looking at, okay, what is the maximum amount these channels could be driving? And then you can work backwards. Tracked metric alignment. This is going on the idea you still have this track data. You can look at how clicks per spend is varying over time. You can look how your touch-based attribution is varied over time. And you can reason about directionally, is your MMM with these time-varying parameters aligning to the broad strokes of track directional change? And this can be a way to build confidence in your marketing mix models. And then this is probably a really interesting one. So incrementality tests, conversion uplift tests, geo-lift tests, these are usually considered gold standard in marketing measurement. The main thing is that they're limited in terms of they take a lot of analytics resource. We need holdout periods to run the tests. And there's business constraints. We can't just do a test because we want to if there's enough of a cost to opportunity cost to the company. So they cannot be a comprehensive measurement of marketing performance. But we can take these results and calibrate the MMM results. We can add them as penalty terms within the model, where, for example, if we say a channel contributes 100 registrations during this time period, we can basically add a penalty term for any difference from this total number over this period according to the model. And this is like very useful. And so these comes in multiple forms. So in a test, you might find the changes in KPI driven by a channel between 2 periods. This is usually done with causal impact, for those that know. And you might also say the total registrations driven by a channel during a period. This is more typical of conversion uplift tests. And what you should bear in mind is most incrementality tests measure total impact. So you need to bear this in mind when you're calibrating within your model. You need to capture both the indirect and direct effects of your channel, and this is what the total number should align to. But there's opportunity here in terms of things we'd usually discard in measurement. So insignificant incrementality test results can actually be useful, and providing no external factors have compromised the test. And so you now have an upper bound for contribution, in a sense. If you have reasonable evidence that the contribution is below the minimal detectable effect because you weren't able to get a significant test result, you can now say that this change in your KPI from this channel is below this threshold amount, this minimal detectable effect. And this becomes the third way that you can use incrementality tests to calibrate your marketing mix models. And then finally, how do you take all this together and iterate as a team? So firstly, you can coordinate scale-ups. One of the big things is how do you introduce new marketing channels and measure them as soon and quickly as possible? So if possible, test first. When introducing new channels, we're in a data-limited environment. So certainty can be sped up if you first experiment with a channel, get an incrementality test, and early doors, we can calibrate the MMM with this incrementality test. We also want to decorrelate it from market growth. This is the very classic problem that we've run into at Wise a lot and that we mentioned earlier, where you want to decorrelate it from market growth. You don't want to just grow a channel investment with a growing market. You need a turn-off event to make sure that there's data evidence of what this channel is actually doing to your KPI. Making recommendations. So modelers will know best what data signals and tests they need to improve model certainty and improve measurement. But marketers will know best the barriers to experimentation. So the opportunity cost of lost KPI, investment freezes that will be required during incrementality testing, and the difficulty of coordinating asynchronous spend changes across spend channels, different marketing channels that might be managed by completely different people. So in this sense, recommendations by data scientists should be few and prioritized, and they should be justified with the consequences emphasized. An example discussion is, we've previously turned off spend. Why do we need to again? We've already done these big tests. Well, the answer can be, well, investment has actually, from our perspective, been constant for a year. Over time, we're losing certainty in channel performance. That is why we're asking you again for this turn-off event. And finally, measurement, it should be viewed as an iterative and collaborative process, and this should be stressed. It is likely that your marketing measurement will improve over several iterations, aka something you previously said was wrong or not quite as right as you'd like it to be. It's important that marketers and data stakeholders both feel involved in this process, so we work progressively together towards truth, and everyone has a knowledge domain to contribute. Incrementality testers who may be data analysts, scientists who are creating these very magnifying glass, high precision test results, work with marketers who are the drivers of performance change, local optimization as they work in their day-in basis and see the live tracked performance, and MMM modelers who know the data signals needed and are creating these measurements of channel performance and certainty. Yeah. Here just thought I'd leave with some technical docs, papers, case studies, theory for causal inference, DAG discovery, Bayesian statistics, and economics I found useful. And yeah, stay to talk for any questions.
Hello, testing. Can you hear me? Is it fine?
Just about.
Thanks for the presentation just now. Hello. Yeah, I think my question is around, back when you first introduced this whole deck, you mentioned about the rise of privacy and also how attributions is getting trickier and trickier. Because I used to work at a bank, and also we're very heavily regulated about how we're able to track things. And how do you see that trend coming into this, so that, because eventually you wouldn't be able to tell who is who. It's just a blurry pixels of who is coming from which channel, if I imagine it correctly. So how do you see the end game of this? Because previously, when I was using Adjust back then, previously it relies a lot on exactly which devices are looking at which ads, and then gradually we can trace them bit by bit. But as that's, it's just less and less possible to do this. How do you see this going? Yeah. Thank you.
Yeah, I think that's why there's been this, because we still have channels at Wise, for example, that have quite a lot of tracked data. But we're moving to these privacy-first approaches that don't require tracked data because we know it's on the horizon. It's a bit hard to predict. Like, I think companies bear in mind how much control Apple has. Bear in mind how much control, I believe that now cookie thing that Google is doing is now being pushed back or potentially cancelled. They seem to be changing their minds a lot. So there's what I'd say is a cautious approach where there is no guarantee that you'll keep this tracked data over time. We are seeing, even on a user level, this approach to VPNs, this approach to caring more about data privacy. So assume that's going to happen. I think an interesting thing that I don't necessarily have an answer for is if you think about how this works together with marketing measurement. When we have to work out the lifetime value of an average customer driven by a marketing channel, you do have to use tracked data then, because you can't just probabilistically, at least I don't know if any techniques, know what the LTV of this channel is. So at the moment, we're taking our remaining tracked customers, however limited it be, and go, okay, the LTVs of this customer is this. We're going to extrapolate it up onto all these probabilistically attributed at the aggregate level customers. And how that actually works, that's an interesting one to me. But I think I don't have an answer for that one, but that's something to think about. We might have a good approach for working out how many customers are coming in. That's privacy first, but how that interacts with customer value, that's another thing entirely.
Thank you for your presentation. From my experience in doing MMM modeling, I think one very big challenge is on the KPI selection, because for some of the marketers, when they are running their campaigns, they may focus more on the indirect effect, for example, awareness or brand reputation. So for these campaigns, basically, they are not generating a lot of revenue. So how do you, when you're doing the modeling and selecting the variables and the KPI, how do you balance these objectives to the models that you're building? Thank you.
Yeah, I think it generally depends on what the prime business objective. When you first introduce marketing measurement for your company, what is your top priority? So for us at Wise, it was not so much about awareness, but about these more direct, we're trying to acquire users. I think it is driven a lot by top level strategy and what we care about most. I think we then get into interesting discussions about, you can put intermediate KPIs into your models. You're not actually limited to one KPI in the sense that I talked about putting in a brand awareness KPI that impacts, the TV impacts, and then brand awareness, if you have it tracked over time, can then also be a factor that impacts your more direct daily conversions. And so you can model these interactions. But I think where you put your MMMs first and which KPIs, I think that is a business decision. And I think that's also a decision that should be led by marketers, because it's about what empowers them to optimize and what we have the best data for. Like, I think we talk a lot about, we want channels, we have this limitation in modeling where we need channels to be consistent in their definition, at least to some degree. Even we've allowed for varying return on investment, it needs to have a consistent definition. So we tend to define it not by these upper awareness campaigns, but more these consideration lower in the funnel campaign types. I think that for the other ones, it's about working with other forms of marketing measurement you might have access to. So you can do all manner of conversion uplift or geo-tests for these awareness campaigns, and maybe discussions with different ways to measure these channels if it's not through your core marketing mixed model approaches. If that makes sense.
Thank you for the very interesting talk. You mentioned about the correlation from market growth or something like this. It's not clear how you implement this correlation. It's often useful when people need to take decisions based on whatever variables you have under control. So how do you implement the correlation?
Decorrelation.
Yeah.
Yeah. So in this case, what we're usually looking for is just turn-off events in the simplest way. I think for Wise, we had a very good example of a channel that was had been strictly increased in a market that was quite high growth, and this channel was performing according to early mixed models very well, but the data itself is very limited. It could just be background growth effects. So the main thing you want to do here is have turn-off events for these channels and negotiate that with your marketers. Because if you don't have this, if you just grow investment with background growth that in a market that's growing, it could give any amount of credit, which is just background growth, to your channel. The idea is we can only learn impact on KPI from how changes impact changes in KPI. So you can't just have these smooth increases in investment.
Thanks for your talk. I got a question on the indirect effect. So you mentioned in TV, there's indirect effect that's more, how do you go about adding indirect effect to your MMM modeling?
Yeah, so what I'd recommend for this is the recast documentation. I'm actually taking this from, we haven't actually implemented it ourselves at Wise, but I've read it on recast, which is I believe they give MMMs as a business service. They're one of those marketing attribution, but they have great technical docs. But basically the essential line is that you can measure if you model these, let's say you have things like paid search brand, and that's driven in part from background demand in the market, people just searching your name. But then if you imagine they saw a TV ad and then they immediately Google searched you, that credit should really go to TV. So if you model your branded paid search as a Gaussian process, as something that and you need limited flexibility here, or it will just all go to the Gaussian process, but plus some transform of your TV impressions or your TV spend, then you can kind of backtrack what of your branded paid search is actually coming from your TV. And then once you have that relationship, and then you model at a lower level the relationship between brand paid search plus TV equals KPI, then you can work out, once you have the number for your total branded paid search, search, you can then reattribute. So if you say 40% of your branded paid search is being driven by TV, then 40% of the causal impact of branded paid search is actually going right back to TV. So like this is how they do it. It's quite an interesting piece of work.
All right, thank you very much. We have come to the end of this session, and we are going to the next one. Thank you so much, Becks. Thank you. A round of applause for him. Okay.